Okay, so this time I'm just going to add some AES instructions. So we'll start with AES decrypt to begin with. So let's just go to the encoder tests, and we'll just add them at the top here. So we've got AESDEC. So this has RM and RVM operand encodings. So this first one can be XMEM0 with XMEM1. Then we've got XMEM0 with RCX as a memory access. Then we've got some VEX encoded ones, which are the same, but they also support YMM. And then we've got some EVEX encoded ones, which go up to ZMM. But these ones don't support anything like opcode masks and stuff, so to force the EVEX encoding, I'll just have to use a high register again. Then we got this AESDECLAST, which is exactly the same. It just does a different thing. So we'll just copy this and put last onto the mnemonic. And then I'm pretty sure that encryption. So we've got AESENC. These ones also have the same operand encodings, so we'll just copy all of these and change DEC to ENC. And we'll just do all of these at the same time. So let's just go and get all of these comments. Transform them into the tests and then align them with each other. So that looks like it's all okay. So let's just go and get all of the mnemonics as well for these ones. Let's go to mnemonics. We'll just add them to the top here. Let's just deduplicate them. Maybe separate them out a bit like this. Okay, let's go and add these to the name table. And then we'll go and add them to the forms. Okay, so let's just run NASM to regenerate the listing. Go test should fail, so that's fine. So let's fill in the forms. So we've got AESDEC first. So this one is going to match on a width of x word. Op_n for this is op_n rm. Op_1 can be vec, and op_2 can be vec or memory. This one has a prefix of 66. I assume it has a map. It's got a map of 0F38. And then the opcode for this one is DE. So that's the legacy one. Then for the VEX one, we've got a family of VEX with X word. It also supports Y word. Then we've got the same prefix, the same map, and the same opcode. And then we've got the same thing, but for EVEX, and this one also supports Z word. Okay, so we've got some incorrect bytes coming out here. This is 660F38 DE. This is probably because this should be op_n VM. Op_2 is only vec, and op_3 is vec or memory. Okay, so now it's on to the oh, this is a VAES deck, which can't match anything anymore. This is because my NASM tests are actually wrong. So these ones should have an additional operand. So let's just try that again. I'll just get rid of all of these. So the vex ones here should have XMM2, XMM1. Let's just do this again. So these ones become YMM. Then we copy this, we'll change this to a high register to force evex, and then we'll make a copy and call this ZMM. This one can be copied, and we'll call this AESDECLAST, and then we'll copy all of these ones again. This is now, instead of dec, this is now enc. Okay, so now it's saying AESDEC can't match. Okay, that's just because I need to generate the tests correctly. Okay, I think that should now be correct. Okay, so now it's saying AESDECLAST, which is correct because I haven't done the form for that one yet. So let's just copy these because they are the same, you know, overall form, and we'll just put last onto this. So the difference here is that the opcode is df. Let's go and look at enc as well. Enc is the same, but it's dc and dd. So let's just copy these. And instead of de, this will be dc. And then instead of df, this will be dd. Yeah, I need to update the names here. So instead of dec, this should be enc. Okay, so let's do the other AES ones here. So we've got AESIMC. So let's go to the test. So we've got AESIMC. This is RM. And there's only one vex version of this. This one looks like it's the same, but it's got RMI. And there's only one vex of that as well, so we'll just copy this one. This is now AESKEYGENASSIST. And these have an immediate on the end, so I'll just do 7F here. Okay, let's just get all of these. Make a copy, go and do the test generation, align everything up. Okay, I think that is all okay, so let's just take these mnemonics here, and we'll add them down here. Okay, copy those. Right, let's go to the forms. Okay, so let's just assemble and do the test. So this now doesn't match on AESIMC. So let's just go and match this. So this is always X word. Op_n is op_n rm. And op1 can be a vec, op2 can be a vec or memory. We have a prefix still of 66. The map is 38. And the opcode for this one is dB. Then for the vex one, we've got family vex. We still just match on the same stuff, same opcode and everything else, so that's fine. So let's copy this one. Instead of IMC, this is a AESDECLAST. And this one is 3A as the map. And the opcode is DF. But the op-n for this one is RMI. So these need an extra operand. So we've got op3 is an immediate 8. Okay, that all works. And there's one more thing that I want to add here, which is the carryless multiply. So that is a PCLMULQDQ. So this has a bunch of different forms here. But the vex and evex ones are the same as each other. Okay, so let's just go and add a test for this. So this is PCLMULQDQ. So we've got RM for the legacy. Then for vex, we've got, oh, and I need an immediate on these. So this is going to be 7F because this is immediate 8. Then for the vex one, we've just got an extra operand. So let's just put vex. We've got an extra operand here and here. Then it does support YMM. So we'll go up to YMM. Then evex is just the same stuff, but it goes up to ZMM. So it's force evex here as usual. I'll just add a high register. I think that is all of them. Okay, that looks correct. Let's just add these mnemonics. And we'll go and add some forms. Okay, let's reassemble. Let's just go and check the assembly this time. So LST. Yeah, that looks like it's okay. Right. So now this should fail on matching a form. So let's put the form in. So the form is always X word for the legacy case. Op-n here is op-n RMI, I think. Yeah, RMI. So that's op1 is vec, op2 is vec or memory, and op3 is immediate 8. Then we've got a prefix of 66. We've got a map of 3A and an opcode of 44. I've got a syntax and error in here again somewhere. I've got 2 op-ends, there we go. Okay, so for vex and evex, these now accept 4 operands. So this is RVMI, and op2 is vec, op3 is vec or memory, and then op4 is the immediate 8. But this still has 663A and 44. So we just need to add family to this as well. This is the vex family. Let's see, syntax errors. I'm missing a colon. There we go. Okay, then we've got evex, which goes up to z word. So this needs to go y word and z word. And then the vex one needs to include y word. Okay, that's everything.